This video will demonstrate a product case study on the manufacturing processes made before a PlayStation 4 controller. This presentation was created by Michael Acosta, Benjamin Parkin, and Matt Shaheen. These images show the controller progressively being taken apart. The first step was to remove the backplate cover, and then to remove the battery pack and the plate for it, then finally to remove the front casing from the PCB board. A layout of all the main components are shown here. The front and rear plastic casings, along with all face buttons of the controller, is evident to be manufactured by injection molding, as there are appearances of bosses circled in yellow, rids circled in green, and ejection pin markings circled in orange. These markings are also evident on the plastic thumbsticks and battery holder. An alternative process that may have been used is casting, but it is not ideal as it has a low throughput and high cure time compared to injection molding. There are two processes used to solder the components onto the controller's PCB board. Wave soldering was used to solder the through-hole components, as the protruding wires are large enough to be soldered without overflowing onto other components. Evidence of wave soldering is circled in red. Reflow soldering may have been used for the surface-mounted components, as they show no signs of overflow and are not through-hole components. Such components are circled in green.
Wire drawing is the process that was used to create the wires for the battery and the rumble packs to connect to the PCB board. The wires are made by pulling a cylinder of wire through progressively smaller dies until the desired cross-section is reached. Liquid injection molding is the primary method of creating intricate parts from a complex mold. Liquid silicone rubber is injected into the mold and produces each part with a uniform design. Injection molding has the highest production rates when compared to other processes such as extruding.
The screws here are made by thread rolling. A blank is rolled between two dies to create threading. This process has a high throughput and a low cost. Thread milling can also be used to create screws, but are more for specialized purposes. Thread milling has a high cost and a low output. These metal weights are created by extrusion. They were extruded through a semicircle die. Then they were cut along the profile with an extrusion saw. The base part was made from a draw punch. The punch pushed down on a blank into the die cavity to give it the bowl shape.